Hello everyone and welcome back to my channel. This is MK and today's LeetCode daily challenge is a hard problem. It's a hard problem if you want to follow the constraints, which is running time of O of n and space complexity of O of 1, which means we cannot have any extra space other than what is given to us in the input. Okay, but first we can solve it disregarding this constraint, and that means we can have extra space. What comes to your mind as the first solution? Something like hash set, maybe, right? And how do you use a hash set to solve this problem? Yes, you can add all of the numbers in the input to your hash set and then just do a for loop from 1 to n. Oh, why 1 to n? Why 1 to n? That is the first thing that you should ask yourself. What is the range of answer? Like, how small or how big is the answer? And for that, let's go and look at a few examples. If, let's say your input is of size n, in this case, n, let's say, is 4, and you have something like this, 2, 1, 3, and 4. Okay, and as you can see, all of the numbers from 1 to n are present here. So in this case, the answer is n plus 1, because all of the numbers from 1 to n were present here. This is the only time that your answer is going to be n plus 1. That is it. That is it. Otherwise, some number in the range of 1 to n should be missing, right? So for example, something like this. Let's say we have 2, 7, 1, 20, whatever. Okay, and as you can see, the first number that is missing here is 3. And 3 is greater than or equal to 1, less than or equal to 4, which is n. Right? So when you're adding the numbers in your hash set, you can ignore the numbers that are not in this range. This is the first thing that you should think of. This question, always ask this question: what is the range of the answer? How big or how small is the answer? How does the answer look like? Ask these questions of yourself. So let's go and write the solution for this one. I'm going to solve this problem with different solutions as well, but I'm going to write the code for each solution first and then move on to the next solution. So what we need is we need a set. Of course, we can call it scene. For example, it's going to be a set of number, and we will initialize that with a new set. Okay, and then we are gonna do a for loop over our nums array, and if x is greater than or equal to 1 and x is less than or equal to n, we are going to add it to the set. But first we need to define n is going to be nums.length, and here scene.add x. Now that we have added all of them to our hash set, in this case, this set scene, we can do a for loop starting from 1 to n. So for let I is 1, I less than or equal to n, I plus plus. If scene.has I, return I. Simple, right? And if we cannot return anything here, that means the answer is n plus 1. That means all of the numbers from 1 to n were present, and we didn't return. So we return n plus 1. You can actually add this return to this for loop. You can just go until n plus 1, but yeah, but it's more explicit to do it this way. I like it this way. It's more explicit to do it this way. Let's run it and see if this is correct, and then we will move on to the next solution. Okay, we have 3 green flags. Let's submit. Okay, accepted. Let's move on to the next solution. So for the next solution, we will build on this intuition. And that means for the second solution, you should whenever someone asks you to do an algorithm that is of one or constant space, that means you can use input. You can use the array or set or whatever has been given to you in the input. You can use that. You can modify that. You can use it for some purpose. And in this case, based on the insight that we got from the first solution, and that insight was the answer should be in range of 1 to n, or it is n plus 1. So what does this mean? If the answer is in range of 1 to n, what does this mean? That means we can use the input as a hash set. We can use input as a hash set. How? Let me give you an example. Let's say we have something like this, and I'm going to show you the final result and then explain to you how we can do that. Let's say we have modified input. Let's say we have modified input, and this is the end result. It's negative a, it's negative b, is plus c, and it's negative d. I have used a, b, c, d because it doesn't matter what the number there is. It doesn't matter. It could be anything in range of 1 to n or anything outside of that range. What matters is the sign of this number. So the indexes are 0, 1, 2, and 3. Okay. And what we have done here is we have converted 1 to n. We have converted that to 0 to n plus n minus 1 in order to be able to use that as indexes. Okay. So negative 1 means that somewhere in input we have seen 1. If you want to convert 1 to an index, you should subtract 1 from it, so it becomes 0. So 1 becomes 0. We go to index 0 and we change the sign to negative. That means, hey, we saw 1 in input because the sign is negative. Negative b means 2. Negative b here at this index means that in the input 2 was present. 2 was present, and we converted 2 to 1, and then we go to index 1 and we say, hey, you are going to be negative. That means I have seen 2. I have seen number 2. I'm going to change the sign of you. And the first number that is positive, that is the missing number. In this case, 2, and that is actually 3. Right? Because index 2 is representing number 3. Index 2 is representing number 3. So in this case, the answer is 3. So let me give you an actual example. Let's say we have 1. Let's say we have 5, 2, and 4. Or 14, whatever. Okay. So here 1, when we see 1, we go to the index 0, 1, 0, 1, 2, 3. These are the indexes. So when we see 1, this is the number 1. We say, hey 1, you are in range of 1 and n, right? So I'm going to consider you. If it's not in range of 1 and n, I'm not going to consider that. But 1 is in range of 1 and n. N is 4 in this case. So I'm going to consider that. So 1 becomes 0 in order to become index. So 1 is the number. And the index that is representing 0 is representing 1 is 0. So this is the index. So this is basically the hash key. This is basically the hash key. And we go here and we say, hey, you're going to be negative. That means I have seen you. So I'm going to change the sign. 5 is not in range of 1 and n. 2. So 2 becomes 2 becomes 1, and 1 is the index, right? So I go to index 1 and see 5, and 5 should become negative 5. 5 should become negative 5. And the last one is 14. Again, 14 is not in range of 1 and 4, so we ignore that. All right. So now the array looks something like this: negative 1, negative 5, 2, and 14. Okay. And now we start from the first one. This is negative, so we have seen it in the input. This is negative, so we have seen it in the input. This is positive, so we convert that index is 2. We convert that to a number, and that number is 3. That means number 3 was missing from input. And 1, 2, and you can see the smallest positive integer. Something that we should note here is that if the numbers are negative in the first place, that is gonna confuse us. So we should take care of the negative numbers first, then move on. How do we take care of negative numbers? So let's say we have negative, let me do this, negative 1, 4, negative 5, and 2, something like this. So what we need to do is we want to convert all of the negative numbers and all of the numbers that are not in range of basically 1 and n to some number that is valid. So my suggestion is number 1. So we convert all of them to 1. What is the problem with this approach? The problem is that 1 could be the answer. 1 could be the smallest missing positive integer, which in this case is. In this case, 1 is the smallest positive integer that is missing from input. So we just check that. If 1 is not present, we return 1. So if 1 is not present, we return 1. Yeah, when 1 is not present, that is easy. That is the smallest positive integer that is missing. That is actually what the question is asking, the smallest positive integer. So if 1 is present, let's say 1 is present, and I'm going to change one of them to 1. Let's say I'm going to change this to 1. If 1 is present, convert all of the other numbers that are not in this range to 1. And now you can do that safely because 1 is present. So we say, hey, you're going to be 1. And if we have other numbers like 15, 22, whatever, we are going to convert them to 1 as well. And after we are done, we go back like this, and we look for the first positive number. And if all of them are negative, that means the answer is n plus 1. If all of them are negative, that means all of the numbers from 1 to n are present. Okay? Let's go and write the code. Delete this code. Now, what we need to do is first check if 1 is present. So if not, if nums.index of 1 is negative 1, return 1. If that means 1 is not present. Otherwise, get n. So n is nums.length, and do a for loop and change everything that is not in the range of 1 to n to 1. So let I is 0, I less than n, I plus plus. If nums I is less than or equal to 0, or nums I is greater than n. If it's less than 0, less than or equal to 0, or if it's greater than n, nums of I should become 1. That's it. Okay. Now we go and do our for loop and change the sign of the corresponding number. So another for loop. For let I is 0, I less than n, I plus plus. So let x equal nums equals math.apps nums I. let I dx equals x minus 1. So why do I get the absolute value? Because num I could already be negative, right? And remember, all of the numbers, absolute value of all the numbers are in range of 1 to n. That's what this for loop is doing. Okay, so I dx should be x minus 1 if nums of I dx is greater than 0. That means this is the first time that we are seeing x. So here we go and say, hey, nums of I dx should be negative. Okay, so we change the sign to be negative, and we do that only once. So if we see x several times, we only change the index only once. All right, so it's not gonna be any problem. Now we do a for loop for let I is 0, I less than n, I plus plus. If nums of I is greater than 0, if it's positive, that means I plus 1 is the answer. So return I plus 1. And if we cannot return here in this for loop, that means all of the numbers from 1 to n are present. And here we return n plus 1. Okay, and let's run and submit. Okay, second solution. Let's move on to the third solution. So for the last solution, let's say we have a list and the list is sorted. Is it going to be easy to find the answer if the list is sorted? And by sort, I mean every number should be in its correct position. So let's say we have something like this. We have 1, 2, 3, 4, 5. So how do we know in this case that the answer to this example is 6 or n plus 1? How do we know that? So we go to 1 and we say, hey, this is 0. The index is 0. The index is 1. The index is 2, 3, 4. We go here and see nums of I is equal to I plus 1. So nums of 0 is 1. Nums of 1 is 2. Nums of 2 is 3. Nums of 3 is 4, and so on. Nums of 4 is 5. So whenever the first index, in this case, the first index that nums of I is not equal to I plus 1, that is the answer. Let's say we can do this. Let's say magically we can do this and sort them. After we have sorted them and after we have put every number in its own place, this is the condition to find the first positive, the smallest positive missing integer. Let me give you another example. So, and see how we can actually sort it. So this is going to be 2, 4, 1, 5, 3. So 2, 4, 1, 5, and 3. Let's see where should each number go. So 2 should go here, right? 4 should go here. 5 should go here. Then 3 should go here, and 1 should go here. Do you see this? This is a cycle. Why does this happen? Because all of the numbers are in range of 1 to n, and we know the place for each one. So 2 should go into index 1. 4 should go into index 3. 5 should go into index 4. 3 should go into index 2. You see that? And if we follow this pattern and see where each number should go, we will have some cycles, some disjoint cycles. So this is a small example. I can just combine this with another example and go to 10, and then you will have 2 cycles, something like this. And sorry for my poor example. So you can have several cycles and put everything in its own place. And And you can solve this with just one. You can put every number in its own place with one while loop. Let's go and see how we can do that. So we start from here. So we have 0, 1, 2, 3, 4. And we look at this index and say, hey, where should you go? This should go to index 1, right? So we swap them. So we just swap them. So this should become 2, and this should become 4. We don't move yet. We don't move yet. We ask the same question. 4, are you at the final position that you should be? And 4 says, no, I should go to index 3. So we swap them. So this becomes 4. This becomes 5. We don't move yet. We don't move yet. And we say again, hey, 5, are you where you should be? No, it should be swapped with this 3. So 5 and 3. We don't move yet. We ask 3, where should you be? It says, I should be at index 2. So we swap them one more time. And as you can see, this is now in sorted order. 1, 2, 3, 4, 5. All right, and we do this. And after we are finished, we just check for the first number for the first index that this condition happens. Again, in this algorithm, we are using an in-place algorithm. We are modifying input. The only difference with the previous solution is that we are moving the numbers around. We are not changing them. We are not, like in this example, we were changing them. Here we changed all of the numbers to 1. But in this solution, we are not changing the numbers. We are just moving them around. And we ignore any number that is not in the range of 1 to n. That's it. Okay? So let's go and write the code for this one. I'm gonna delete the code. So what we need an index I, should be 0, and while, and let n to be nums.length. So while I is less than n, okay, if nums I is out of range, so if nums I is less than or equal to 0, or nums I is greater than n, we just move on. So continue, okay. Else, if it's in range, so we are gonna find the index. So let idx be nums I minus 1 if nums of idx is not equal to nums of I. All right, okay, we swap them. So let temp be nums idx equals nums I, and nums I becomes temp. Okay, and we don't move yet. We just, if this is the case, that means nums I is where it should be. So we just move to the next index. Okay, and after we are done, we do the same for loop we did for the previous algorithm. So let I is 0, I less than n, I plus plus. If nums I is not equal to I plus 1, we return I plus 1. Sorry. And then we return n plus 1 if that doesn't happen. Okay, let's run this. And yeah, submit. All right, this was the search solution. I hope you enjoyed my explanation. Please like and subscribe if you haven't done so, and introduce me to your other friends. Thank you. If you like, please.